Welcome back to VLSF for All. In this series, we are going to discuss digital interview questions which might be helpful in your interviews as well. Let's get into the series. First question is, find out the simplified expression for y in terms of a, b, and c. What is the figure given here? 4 is to 1 marks. It has two select lines a and b and 4 inputs and one output y. See what he is asking. Simplified expression, no? So according to the characteristic equation of the 4 is to 1 marks, we have to write the equation. What is the equation of the 4 is to 1 marks? S1 bar, S0 bar, I0 plus S1 bar, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. This is the equation, right? According to this equation, we have to write the given form. See, y can be given as, we have to write, see, according to what are the select lines here, A and B, A bar, B bar, and here first input I0 is C, and A bar, B, and I1 is C bar here, and A, B bar, and I2 is C bar here, C, A, B, and I3 is C. We have written the equation like that. Now we have to simplify. We have to see what are the common in the both of them in all the equations. See here a bar, a bar. A bar is common, right? So a bar is taken out of it and b bar c plus bc bar. See here it is taken as common and we have written the equation. And here also a is common. B bar c bar plus bc. Again, if we consider this equation, see b bar c plus bc bar, it was like an XOR gate. It characterized like a XOR gate. So b XOR c. Here, if we see this is an XNOR gate, b bar c bar plus bc. But if we want to write it as an XOR form, what we have to write? B XOR c whole bar. Then we have like an XNOR gate, right? Now, if we write like that, if we take this as x, entire expression as x, a bar x plus a x bar, what it means? Again, it forms an XOR gate. So, what we have to write? A XOR x. What is x here? B XOR c. So, we got like full adder. A XOR B XOR c. Now, next question. What is transparent latch? See what transparent latch? I think you listen anywhere. Did you listen anywhere? Means so many people know D-latch, but no one knows D-latch is also called as transparent latch. What if this was asked in your interview and you are not able to say what D-latch is a transparent latch? You will use it like so. See here, D-latch is also called as transparent latch. You may ask why? Because here, as it transfer the data as it is to the output on enable signal. When the enable is high or when the clock signal is high, we will transfer the data as it is to the output. Otherwise, it will be no change state. That's why D-latch is also called as transparent latch. Why? Because D-latch is used to capture or latch the logic level which is present on the data line when the clock input is high. If the data on the D line changes the state while the clock pulse is high, the output Q follows the input D. Understand? Next question. What is the difference between flip-flop and latch? This is the most repeated question in the digital interview questions. Right? First of all, what is latch and flip-flop? What the main difference? Because if you ask them what's the main difference, you can say first point is latch is a level trigger device and flip-flop is a edge trigger device. If anyone may ask what are the level triggering and what is edge triggering. Level triggering means an event occurs during the high voltage level or low voltage level. Edge triggered means it is edge means passage or negate of the signal it is triggered. What is the difference? Level triggering has some of the disadvantages, whereas edge triggering doesn't have. See, there is no further classification for latches. Latch means latch only. Flip-flop means not like that. It is maybe asynchronous or synchronous. And latches can be worked as without clock or with clock. But flip-flops cannot work without clock signal. They always require clock signal. Latches are operated only with binary inputs, whereas flip-flops are worked with clock signals or otherwise binary inputs. And latches are faster as required to flip-flops. Why? Because latches are requiring only less circuitry and without clock signal. So they always give the output very fast. Whereas flip-flops have some complex circuitry compared to latches, right? Latches are constructed from logic gates and these latches are further improved to build a flip-flop. Further improved means what? They can a clock signal can be added in the latch circuit to behave it as a flip-flop. What other differences? You have any other differences? Yes. We can write drawbacks also. Does latch have any drawback? Yeah, they have. That's why we go to flip flop. What's the drawback of the latch? The latches are responsive to any occurring faults on the enabled pin, whereas flip flops are stay strong against any fault. Now, the next question is also is only what means what we have discussed in the summary of this question. What is that question? Let's see. Why flip flops are preferred when compared with latches? Why flip flops? Now only we have discussed why they are preferred. They does not have clock signal. Without clock signal, any circuit is not synchronous, and they do not have timing and synchronization within the circuit. Without synchronization, how we will be getting the output? We are not getting right. The change in the output state is controlled when it has only clock signal. That is the first difference and first reason why we prefer more flip flops than latches. Next point: a flip flop is capable as working as a resistor. Yes, because it contains clock signal. In latch, we do not have clock signals, and if we want to make latch as a register, we require further advanced electronic circuits. Flip flop is quite easy to perform circuit analysis because analyzing it is very easy because we have clock signal. If we give clock signal enable, and then the output changes accordingly, so we can analyze easily. But latches are not like that, and flip flops are comparatively more robust than latches. Yes, right? You understand, right? Now, uh, that's why flip flops are preferred more when compared with latches. This is the end of the series. Thank you.